Okay. So logical link control functions, we looked at MAC functions, then we can look at the logical link control function. Abstracts the higher layer protocols from the details of the physical link technologies and access methods. It also provides one or more service access points. We know what is an access point is. Access point, it is found, the difference between, I talked about wireless technologies where we have ad hoc and the infrastructure. The difference between the ad hoc and the infrastructure is that ad hoc doesn't need an access point. Just like the way we can, like a Bluetooth, you can connect to the computer, you just, to the phone, you just pair them and they can receive the files. But on the infrastructure network, wireless infrastructure network, there is a need of an access point. For instance, when you go to cyber, you want to connect to the internet, there's need of an access point, then access point is connected to the internet service provider. Okay. So then we'll look at the addressing of users' processes under the logical link functions. Then as in higher level data link control, we have connection management there, frame sequencing, error recovery, acknowledgement, etc., and also the checksum. Then flow control. So we need to know the function of these, like connection management, frame sequencing, error recovery, and flow control. And flow control ensures that the frames are controlled during the transmission, not to cause, when the frames are controlled, we'll make sure that there will be no congestion. When there's a congestion will render the network into useless. The network will be very slow and so on. Then error recovery, it's just about recovering those errors from those ones which have been corrupted. Then frame sequencing, these frames are in sequence as they are being transmitted. We'll explain more on frame sequencing, especially on the transport layer. So these frames, they are given sequence numbers. These frames have got sequence numbers, so that when they arrive at the receiver, these frames, they can be packaged together, deassembled. We talked about assembling and deassembling. Then connection management, just to make sure that there's a connectivity between the sender and the receiver, or between the two devices. Then contention, Ethernet, CSMA, which stands for Carrier Sense Multiple Access. Stands for Carrier Sense Multiple Access with collision detection. CD stands for collision detection. So this happens in wired, in Ethernet. Collision detection, meaning that the stations on the network, before they can send their frames, they have to listen to the link to find out if that link is free or not, to avoid collision, So it will detect the collision if at all it senses that there is another station which is using this link. Then this particular station won't send that packet, because if that station sends packet, another station sends packet, these frames will collide. So this technology called carrier sense multiple access with collision detection. Then in wireless, there is carrier sense multiple access with collision avoidance. It avoids collision. Okay, it avoids collision. Even in this technology in cars, it's also there, whereby even if the car can sense a pothole, the car will automatically stop to avoid the collision. The car can sense that there's another car in front. If the driver can't see, it automatically stops. But not in Zambia, it will never work. You might have an intelligent car like this, but what about the person who's following you or the person you are following? Your car will stop and someone will come and bash into your car. Then there is also round robin. This one is used in token passing. This one is used in token rings. Okay. There's a token that moves along the ring and clockwise and clockwise. So if there are computers, there's this computer, one computer wishes to send the packet, it will get a token from a ring and places the frame on that ring. Then when that ring goes back to the ring, it will start going to its destination. So when the destination receives that ring, it will get the ring, removes the frame, and places back the acknowledgement so that the ring, the token can continue until the sender, the one who sends the packet, removes the ring and get the acknowledgement, say, read and say, okay, that frame I sent received. So now I can release the token. So the token will be released again. It will start going around the ring until another station that wants to send the frame also will get that particular token. Are we clear?
Yes.
Okay. Then there's also technology like polling. Then we have also the reservation. So we'll concentrate more on the Ethernet, round robin. There's also even the polling and also the reservation. I'll explain more on the polling as well as the reservation. IEEE stands for what? It's a standard. What are the abbreviations for IEEE? No idea.
No idea.
Is it Institute of Electrical and Electronics Engineering?
Yes. Yes. That's what it means. So it is a standard. So IEEE and S and CSMA/CD. What about this one? Stands for what? Just from talking about it. Nothing.
Nothing.
You have forgotten.
Sorry, which one?
Carrier sense smart coaxial with collision detection.
Yes, yes, carrier sense smart coaxial with collision detection. So all this is Ethernet technology. It is Ethernet technology. So let's look at the...
So in carrier sense multiple action with collision detection?
Yes, that one. It's where? Yeah, it's carrier sense multiple access with collision detection. There's also carrier sense multiple access with collision avoidance. That the collision avoidance is used in wireless technologies. Collision detection is used in wired technology. Okay, let's look at the IEEE 802 committee. The Local Area Network and Metropolitan Area Network Standards Committee. We have LMS or IEEE Project 802 develops LAN and MAN standards mainly for the lowest two layers of the OS model. Active working groups. When you find the standard code 802.1, this is a high-level interface, Then 802.3, this is the 802.3, this is wired, okay? Remember I talked about it. CSMA/CD is for wired Ethernet, right? So I might not say wired, I'll just say 802.3. You have to know that I'm talking about a wired, okay? Then 802.11, it's wireless, okay? 802.11 it's wireless, although it has come up with versions. We'll discuss the reason why for those versions. There's 802.11a, 802.11b, 802.11g, 802.11ad, 802.11af, just like that. I don't know if you've come across with those versions of wireless. Then we have 802.15. This is a wireless personal area network. This is wireless personal area network, which is 802.15. It's actually WiMAX, okay? The other name we can say a WiMAX. Nothing. Then we have 802.16. This is actually broadband wireless access. Or should I say this is Bluetooth? Oh, no. 802.15 is Bluetooth, wireless personal area network is Bluetooth. What is a personal area network? A personal area network is a network that you can create on your own, your computer, your phone, your printer, the keyboard, just like that. If I may ask, what technology is used in such a scenario? What technology is used in such a scenario? Are you listening?
Rephrase the question.
I was saying, in a personal area network, I'm explaining about a personal area network. A personal area network is that network you create where you can connect your printer to the phone to the laptop. Maybe you can create another, you can connect the TV, or maybe you can connect the home theater, that kind of connection. What technologies is used? Okay, how do you connect your phone? Maybe to your TV?
To the internet?
No.
Oh.
How do you connect your phone? Okay, how do you connect your phone and the laptop?
USB.
Apart from USB?
You can use multicast.
Multicast. Look at
where
it.
You share the screen.
It says 802.15 wireless. So there is no cable involved there. Bluetooth is a technology. Are we together?
Yes.
Bluetooth. So the technology is for 802.15. So this 802.15, it's a Bluetooth. Whereas 802.16, it's a
broadband.
Yeah, broadband wireless access, which is a WiMAX, isn't it?
Yes.
Then we have 802.17. This is a resilient packet ring. 802.18, it's radio regulatory technical advisory group. Then 802.19 is coexistence technical advisory group. Then 802.20 is mobile wireless access. Mobile wireless access. Although we concentrate on 802.11, which is wireless most of the time. Then also 802.15, it's Bluetooth, it's still in use, it's there. Then 802.16, it's broadband wireless. Then these are active working groups. Then we have those groups which are on hibernation. Hibernating working groups, standards published but inactive. We have 802.2. This is a logical link control, which is found at the layer 2. Then we have 802.4, which is a token bus. 802.5, it's a token ring. 802.6 is MAN, Metropolitan Area Network. Then .7 is a broadband technical advisory group. .9 is integrated services LAN. .10 is a standard for interoperable LAN security. Then .11 is demand priority. Let's understand these 802 IEEE 802 committees. These are IEEE 802 committees. Let's not forget these. They are very important. Okay, let's look at the logical link control. Logical link control provides an interface between the various network technologies, and the upper layers hides the difference between the technologies from the upper layers. Okay, so look at the data link layer. It is showing 802.2, which is a logical link control. Then we have also the physical layer. So 802.3, this is a wired, which is the carrier sense smart access with collision detection. It's a technology used in wired. Then 802.4, it's a token bus. .5, it's a token ring. .6, it's a metropolitan area network. Then what you see below, it's a logical link control frames. Logical link control frames. DSAP address, which is a 1 byte. SSAP address, it's also a 1 byte. Control is 1 or 2 bytes. Information or more bytes. So this one provides an interface between the various network technologies and the upper layers. Hide the differences between the technologies from the upper layers. Which one are the upper layers? Starting from actually network layer, transport layer, and network layer, transport layer, and the application layer. So layer 3, the PDU, it's a packet, okay? Then layer 2, the PDU, it's a frame. It is a frame, PDU frame. So the packet at layer 2, the header is added, then the payload. A payload is the actual frame which is being transmitted. Then layer 2 MAC, it had the MAC address and the payload. A payload is the actual frame I said. Then the layer 1 is dealing in bits, those zeros and ones. They are actually bit streams. So it's these bit streams which can be converted to the signal. So it's this bit stream which is converted to a signal. And Ethernet technology, the dominant LAN technology in the world is Ethernet technology. It's not that it's the only one, it's just a dominant. Operates in 2 areas of the OS model. It operates in MAC sublayer of the data link layer and the physical. Okay, not one technology, but a family of local area networks technologies. Various specifications supports different media bandwidth and other layer 1 and 2 variations. However, all the specifications are essentially compatible with the original Ethernet standard. Essentially, frame format and addressing schemes, the same for all varieties. The same protocol that transported data at 3 megabytes per second in a long time ago in 73, it is now carrying the data at a faster link, which is 10 gigabytes per second, okay? Then Ethernet is considered very scalable. The bandwidth of the network can be increased many times without changing the underlying Ethernet technology. E.g., Ethernet frame can be created by an order coaxial cable, which is 10 megabytes per second network interface card during its journey travel over a 10 gigabytes Ethernet fiber link, and can be eventually delivered to 100 megabytes per second. So what we are saying is that we are saying the link, we are saying for the inside connectivity, we can have a slower links like 100 Let's say we have a network like at the organization. Then in the same network, it is connected to the ISP using a faster link. We can call it a backbone. It is a backbone, isn't it? That's what it means. Are we clear?
Yes.
So this is a kind of a network, a collision domain, and relationship to layer 1 and 2 devices. Collision domain, part of the network bounded by layer 2 or higher devices. A collision will travel across a repeater or a hub. These are layer 1 devices. Will not pass across a bridge or switch because these are layer 2 devices. Will not pass across a router because a router is a layer 3 devices. So look at the collision. So we have these hubs connected to the switch. Each switch, it's a local area network. It connects a lot of computers, okay? Then this topology, as you can see, it's a tree topology. It's a tree topology where we have a router connects the switch, then a switch connects the hub, or a router can connect to the hub, then a switch, then many hubs. Then we can have computers. Then we do have the hub between the two routers. Again, there are two connections there. So Ethernet MAC address are 48-bit in length, expressed as 12 hexadecimals. So they are written in hexadecimals. Bend into read-only memory, referred as a bend in address, BIA, copied into random access memory, RAM, when the network interface card initializes. Organization unique identifier, the first 6 hexadecimal digits administered by the IEEE, administered by the IEEE, identify the manufacturer. Okay. Just a minute. So the vendor assigned part, the remaining 6 hexadecimal digits represent the interface serial number. On receipt of a frame, the network interface card checks to see if its MAC address, remember the MAC address is physical address. Physical address, this is what the switches uses to address or to send the frames or the packets. Switches have got a local responsibilities. Only when the station wants to send information to an IP address which is not found in that particular network. So in this case, the switch will forward the packet, the frame or the packet to the router. Then the router can send it to another network, it routes. So on the receipt of a frame, there is a network interface card which checks to see if its MAC address matches the destination MAC address in the frame. So if it matches, the frame is passed to the upper layer. If it matches. If it does not match, the frame is discarded. Okay? The frame is discarded, meaning that it does not belong to that particular network, or the destination where it is sending doesn't exist. So this is a layer 2 framing. Framing means providing a standard representation of information passed over network link. That is, framing is the layer 2 encapsulation process. A frame is the layer 2 protocol data unit, PDU. The frame, we have the 802.3 Ethernet frame. So these are the features of a frame. The first thing we see is a preamble 7-byte of data, which is 10, 10, 10, that's data. Then second is the start of a frame delimiter, 1 byte. Then destination, MAC address, 6 bits. Then source MAC address, 6 bits. So the destination MAC address, meaning that where the address of the receiving computer and the address of the sending computer. Okay. Then length or type, which is a 2 bytes. Then data, the size of the data is supposed to, after 10 minutes, it will time out. So you just log in case we don't finish these slides. So I was saying the data, the actual size is supposed to be from 0 to 1,500. If it's bigger than 1,500, then this data can corrupt the machine. Then the pad is from 0 to 46 byte. Then frame check sequence, FCS, is the one that checks if the data or if the frames are corrupt or not. Then if they are corrupt, it can mend them. So the preamble field shown in yellow, header, field shown blue, payload, field shown red. Note that the frame is considered to start at the information carrying portion, that is from the destination address field for frame size calculations. Then the header is considered to include the frame check sequence, even though it is at the end of the frame. Then the header is about 18 bytes long. 18 bytes long. The minimum frame size is 64 bytes. Thus, the data field plus pad must always total at least 46 bytes. The maximum packet size is 1,518 bytes. That's the maximum. So that's the maximum size data is about 1,500. That's layer 2. Framing continues. Frames are susceptible to transmission errors. The frame check sequence field contains the number of calculated by the source node based on the data in the frame. The FC is added to the end of the frame before it is sent. When the destination node receives the frame, it regulates the FCS number. If two numbers are different, an error is assumed. The frame is discarded if an error is assumed. Then we have NAC is sent to the source, implying that the frame must be transmitted. Not acknowledgement, meaning that not acknowledged. SCK acknowledgement. Okay. Any question?
No question.
Then we were looking at the logical link control. We are looking at logical link control. Then we can look at media access control. Oh, this is a layer 2. This is a data link layer. So MAC protocol determines which computer on a shared media environment or collision domain is allowed to transmit the data. Is allowed to transmit the data. MAC is a sublayer of layer 2. Deterministic media access control, e.g. using a token as in a token ring. So non-deterministic media access control, first come, first served. This one uses carrier sense multiple access as in Ethernet. So carrier sense multiple access with collision detection, the network interface card listens for an absence of a signal on the shared media. Meaning that if there is a signal, it can't allow another computer to send the signal. Otherwise, if it listens and it senses the signal, then meaning that if two signals collide, it will render the network into useless. So if two nodes transmit at the same time, near the same time, a collision occurs, and temporarily, none of the nodes are able to transmit. Look at this diagram. We've got node 1, node 2, node 3. So all these nodes are listening, okay? All these nodes are listening. Look at node 1 is listening and sending, isn't it? Node 2 is listening, not sending, because if it sends, it will collide. All right. Look at node 3. It is also listening and sending. So what will happen to this? What will happen to this because of using the same medium? These are going to collide. These are going to collide because they did not sense. So let's see how the CSMA CD operates. So a node that wants to send data works in listen before transmit mode. Works in a listen before transmit mode. Is the network media busy? So this is to ensure no other stations are transmitting at the same time. Multiple access. If the node determines the network is busy, the node waits a random amount of time before retrying. After completing data transmission, the data will return to listening mode. The network device detects a collision has occurred. has occurred when the amplitude of the signal on the network media increases. So each node that is transmitting will continue to transmit for a short time to ensure that all devices see the collision, which is a jump signal. Then a backoff algorithm is evoked and transmission is stopped. Node waits for a random period of time before it can send again. So when the delay period expires, each device can attempt to gain access to the networking media. If the MAC layer is unable to send the frame after 16 attempts, it gives up and generates an error to the network layer. 16 times, don't forget. Then access protocol, carrier sense LBT, wait till line free, then transmit at once. This is called the one persistent. This is called one persistent. This is called one persistent. Then collision detect, listen while talk. If collision, stop TX and jump signal, which is 2 bits. If collision is less than 16, if collision is greater than 16, we said it will give up. All station wait 96 bit times. If interframe gap 96 bit times or 9.6 nanosecond before sending a frame, those involved in collision wait random interval. BEB algorithm output of slot time, which is 512 bits, per second. So these are collision detection. The first one, look at the first one. Packet starts at time 0. Packet almost at time B, it's about reaching. Then now listen what will happen. If time B also sends, look at those packets, they are going to collide. They are going to collide. When they collide, there will be noise. Look at the last diagram, D. There will be noise. Noise best gets back to A. So station A must detect the collision before it has finished transmitting. Where is the noise coming from?
We'll go see the dog now.
Okay, those are Ethernet topologies. We've got a bus topology. We've got a star topology also. So all these, they use the same mechanisms. These are just topologies, Ethernet topologies. Bus, physical, star. We can have ring, we can have mesh as well. So that is an extended star. As you can see, that's how it looks like, the extended star. Then we've got Ethernet topology logical bus. This is a bus. Then full duplex and half duplex. Full duplex, this is where communications can happen in both directions same time. Then half duplex, communication happens once at a time. I'll give you the examples of half duplex. It's a walkie-talkie, isn't it? Whereas full duplex can be a phone, whereby someone can be talking and another one talking at the same time. It just feels like it's a half duplex because we are human beings, we reason. We can't be talking whilst the other person is also talking. Okay, so full duplex, only one node can transmit at a time in a shared medium, logically bus topology. Then full duplex, both nodes at each end of the private link can transmit simultaneously. Logically, the link is seen as a point-to-point link. Achieving full duplex, in order for both nodes to be able to transmit, there must be 2 carriers. UTP category 5 as twisted pair or wire. In half duplex, only 1 pair is used to transmit, okay? So a full duplex mode, a second pair of wires is employed. 1 wire pair is used in each direction. Each wire pair is dedicated so no collision can occur. Full link bandwidth is available in each direction. The link must terminate at the layer 2 or devices.